Okay, today we're going to be talking about the derivatives of the 6 trig functions, and I'd like to use the definition of the derivative to find the derivative of sine x, because I think it's kind of fun, and well, I'm a calculus teacher. So we use our derivative, f of x plus h minus f of x all over h. Now you have to remember your sum and difference identities. So then we have sine of h times cosine x minus sine of x all over h. Now what I'm going to do is I'm going to group together this term and this term and factor out a sign. So I have sine of x, and I have cosine h minus 1 plus sine of h times cosine x, the whole thing over h. Now I'm going to split it up. Because you can split up your numerator across addition or subtraction. Now let's separate these out even more, because I gave you guys a few important trig limits that I wanted you guys to know. So I have sine of x. Now I'm going to put anything that has an h in it, any term that has an h in it, together. Okay, so now it's a matter of remembering. Limit as h goes to 0 of sine of x is just sine of x. Limit as h goes to 0 of the cosine of h minus 1 over h is 0 from our limits chapter. This limit is equal to 1, and that's equal to cosine of x, so that all simplifies to the cosine of x. Okay, derivatives of the 6 trig functions. You need to memorize these. Derivative of the sine is the cosine. Derivative of cosine is negative sine. Tangent is secant squared. Notice how tangent and cotangent are secant and cosecant paired together. And secant and cosecant are secant tangent, cosecant, cotangent. Notice anything that starts with a co, when you're taking the derivative, has a negative in front of it. So that's just some fun tricks that can help you memorize. Okay, derivative of each. Our first example. Well, this is technically a product. I have f, and we have g. So on the side over here, let's figure out what f prime is. That's negative 8x. And let's figure out what g, the derivative of g is, and from our table, that's sine of x. And again, you need to remember those. So we have derivative of the first, leaving the second alone, plus leaving the first alone. Derivative of the second was a negative sine of x. So simplifying that all out, we have negative 8x cosine x plus 4x squared sine x. If you wanted, I guess you could factor out a 4 and an x, but that's not super necessary. Working with trig, sometimes it's going to make your life easy if you simplify first. So see if we can simplify cosecant, cotangent. Cosecant's 1 over sine x. Cotangent is cosine x over sine x. Okay, so that would simplify to a quotient rule, But I always make mistakes in quotient rule, so I try to avoid the quotient rule. So instead, we're just going to take the derivative using the product. But you do want to see if you could simplify first. Okay, so derivative of the first. Derivative of cosecant is negative cosecant x cotangent x. Leaving the second alone. Plus, leaving the first alone, derivative of the second, derivative of cotangent is negative cosecant squared x. So now it's just a matter of simplifying. I have negative cosecant x cotangent squared x minus cosecant cubed x. And again, you could factor out cosecant if you wanted. That's not super necessary. Okay, this example. There's a lot going on here. So I have a quotient rule, but then when I take the derivative of the top, I would have a product there. And also notice cosecant, cosine times cosecant, you could simplify that. We could technically simplify this even more because cosecant times 1 over sine is the tangent. I'm sorry, what am I thinking? It is cotangent. Okay, now this actually makes our life pretty easy. Because notice how I have a cotangent being multiplied up here, and I have a term with a cotangent on the bottom. If I take it, I multiply by tangent on the top, and both of those terms by tangent on the bottom, we simplify to x squared plus 1. Distribute your tangent through, we get 3 tan x minus 1. That makes our life a little bit easier. Okay, so our derivative is, oh, that was a really straight line. Okay, remember your derivative, the denominator, you can just square. So low, but for the numerator, you have low d high minus high minus high d low draw the line square the below. Okay, simplifying. We get 6x tan x minus 2x minus a 3x squared secant squared x minus a 3 secant squared x all over our denominator. I don't think we can simplify that anymore, so I'm going to leave it like that. Okay, writing the equation of a tangent line and normal line of y equals tangent x at negative pi over 4. So remember, we need a point. Negative pi over 4. The y coordinates when I plug in negative pi over 4 in and I get a negative 1 out. Okay, now to get your slope, you take the derivative. Derivative of tangent is the secant squared. Plug in pi over 4. I'm sorry, negative pi over 4. The negative pi over 4 of secant is root 2. So when I square, I'm sorry, yeah, it is positive. So then we get 2. So our tangent line, y minus y1 is equal to m times x minus x1. And then our normal line, y minus y1 is equal to, our slope we'll deal with in a minute. Remember, slope is, for the normal line, is perpendicular, so it's the opposite reciprocal. Okay, last question. And this one's complicated because we're finding the second derivative, but also we have a product rule happening here. Okay, so y prime. Derivative of the first, leave the second alone. Plus, leaving the first alone, derivative of the second is negative sine x. So I take my eraser and I put in the negative. Plus the derivative of that, which is 4 cosine x. Okay, now your second derivative is where this gets a little crazy. Okay, so this is a product rule. So we have to do that product rule. Derivative of the first, leave the second alone. Plus, leaving the first alone, derivative of the second is negative sine x. So I go with my eraser, and then I take and I put in my negative. Okay, then bring down this minus sign, and we're going to eventually distribute when we take the derivative of this, which is again another product rule. Derivative of the first, leaving the second alone, plus leaving the first alone, derivative of the second, and then the derivative of that final term is a minus a 4 sine x. Okay, I'm just going to go through and do some simplifying because I believe we can combine some like terms. Make sure you distribute correctly. Okay, so I have my 2 cosine x, that's this term. I have those I can combine into minus 4x sine x. That's just a minus x squared cos x, and then minus a 4 sine of x. And that is it for today. Please make sure your submission is on time.